Hello there, my name is Jan Skradek, and in this video I'll demonstrate different ways to add complexity to the meshes in your game while still keeping fairly good performance. So, as with most computer graphics applications, you always have to be careful about just different trade-offs between visual appearance of your application and the performance. Obviously, the more complex the meshes in your game, so they would have more polygons. Um, the more calculations your GPU would have to do, and obviously the frame will be drawn at a longer time. Um, while the first instinct can be to add detail through adding more points on the mesh, there are other ways to do that as well through texture maps. So um, so basically, with most texture map methods, you um, you extract the information you want on each point of the mesh at a pixel resolution, basically, depending on how high resolution the texture is. Um, and you apply it on the mesh based on the texture coordinate. Okay, so the first thing I'm going to talk about is normal mapping. With normal mapping, instead of extracting normals from the vertices of the mesh, you use a normal map texture. So then the normals would be calculated on a per pixel basis rather than per vertex. As we can see right here, um, the light the light which is calculated on the based on normals applied from the norm we can see that the light bounces off as it was a more complex surface, while it is still a fairly simple low poly model of a sphere or a cup. Or as you can see here, this basically consists of just two triangles and four vertices. And if I move a light around, we can see the complexity of the surface. While it is a fairly simple method and it creates a decent enough visual, it still has its own drawbacks. The main drawback, as we can see here, is just the illusion quickly disappears as we see the edges of the mesh, which are still maintained to be which is still a simple outline of the mesh without any rafts or bumps which could be seen on the normal map itself. Another part is that the illusion quickly disappears as you get closer to the mesh. As you get closer to the mesh. So at sharp angles, those normal maps wouldn't work that well. So while normal maps are the simplest way, we can also do some things around topology. So while with normal maps, you feed in the data about normals, you can also feed the data about height. So that would be done for a height map. So the first method I'm going to talk about of just adding complexity for a height map would be parallax mapping. So with parallax mapping, you basically it's basically tricking your eye into thinking there's a depth of the object by doing some calculations and shifting the specific texture coordinates around to create this illusion of depth. And as we can see right here, we can see on the flat surface we can see the outline right here, and we can see that the surface looks much bumpier and more realistic. Um, yeah, while still not adding more vertices to the mesh. Um, while right now this method looks very good, it again it has its own limitations. The main thing is it only works well on flat surfaces. So this has applied parallax mapping. Those objects do not, but it would be harder to create this illusion of depth on spherical or convex surfaces And another point is it doesn't work well on sharp height differences. So as you can see, it basically just samples the height based on the level. So it has a finite amount of levels. So in here you have 32 levels of height, and as we increase the sharpness of changes of height, we can see that the illusion quickly breaks. As you can see, the aliasing between those levels of height. Okay, so um, up until this point, we still haven't added any more vertices to make it more complex. So so comes the last method, which is changing the height of the mesh with the height map, and changing it through vertices themselves. So yeah, as a simple example, so while by itself it doesn't work very well if we just shift the vertices that were provided, but there there is another another way to do it through tessellation. So tessellation is basically a hardware function on on the GPU that split add that adds more that on the render stage it adds more vertices onto the mesh that were provided in the buffer. It works the same way as subdivision in most 3D applications like Blender or 3ds Max. So with those more with so by adding more of those points, you'll adding more of those points and shifting them with the height map, you'll you'll see that you'll actually get a fairly decent result. So we'll see that let's so as I set my tessellation to 10, we can we see the depth of the object even from the even from the close-up. We see that the object has complexity and depth. We can see the outlines of the object. It works well on the on this on this spherical object as well as the pot right here, as well as the pot right here. Yeah, and it also works very good, and it also works well on the sharp differences in height as well, as you can see right here. Yeah, okay, and yeah, we can apply it to, for instance, now, and with that, we can now, with that and the mix of normal maps, we can now create very realistic, very good approximation of detail on those meshes. So yeah, just add a little wooden pot right here. Oh, okay. Yeah. Okay. Obviously, it provides it provides a very good effect, but yet again, it creates more vertices. Obviously, it doesn't create it wouldn't create as many vertices as you would actually have to if you would, for instance, export a raw file without any baking of normal maps or height maps from Blender, but still adds more compute, but still adds um, more vertices that have to be run through geometry shader and fragment shader, creating more computation. So right now I can even do this if I set, for instance, the tessellation to 10. I don't know if you can see it on video, but the application slows drastically. So let's set all those tessellations to 10, and yeah, you can you can see the limitation of this. While there are a lot of vertices, that's basically adding 100 times more vertices. The performance is very slow. Okay, but then again, it works best with while mixing all of them together. So just applying the parallax on the flat surfaces and adding slight tessellation to this, and then uh, also applying normal maps to create a very good representation of, for in this case, a rock or a wood or a snowball. So yeah, thank you very much.